At this very edge of the world, Mother Nature has established a boundary that humanity has never dared to cross until this ambitious moment in time. Here lies a vast abyss, deeper than any bridge could ever reach, where the currents are strong enough to shatter the strongest concrete pillars ever built. Welcome to the Great Rift, a geological scar that has kept two thriving civilizations apart for millennia, guarded by 1,000 meters of freezing, crushing water. This is not just a distance of 50 kilometers. It is a journey through a graveyard of ships and a realm where light never reaches the floor. Traditional transport methods have always been at the mercy of the elements, with ships and planes frequently delayed or destroyed by the ocean's unpredictable fury. The necessity for a permanent, wind-reliable connection has grown from a mere dream into a desperate survival requirement for the economic future of these two continents. But the ocean says no. It guards its secrets with a wall of water and a floor of unstable mud that defies every conventional engineering logic known. Every attempt to bridge this gap has failed in the design phase, as no material could withstand the sheer weight and force of these rhythmic oceanic tides. Engineers have called it the dead zone, a place where the laws of physics seem to favor the chaos of the sea over the order of man. Today we begin our journey into this forbidden territory, a high-stakes expedition into the heart of the abyss, to build what was once considered completely impossible. With the latest advancements in technology and a spark of human defiance, we are finally ready to challenge the absolute authority of the Great Rift's depths. This is the story of the most ambitious construction project in human history, a multi-billion-dollar gamble against the crushing weight of the deep blue sea. Welcome to the expedition into the dead zone, where we will witness the birth of a superstructure that will redefine our connection to the planet forever. Beneath the calm surface, the Earth is in constant motion, with tectonic plates grinding together, creating a volatile foundation that would swallow any normal tunnel. At a depth of 1,200 meters, the pressure is an incredible 120 atmospheres, a force that can flatten most man-made objects. To understand the scale, every square meter of a structure down here must support the weight of an entire herd of 10 massive African elephants. It's not just the pressure. The salt-heavy environment is incredibly corrosive, eating through standard steel and concrete in a matter of a few short years. The seabed itself is a chaotic mix of unstable mud and brittle limestone, making traditional drilling and tunneling a suicidal mission for any engineering crew. If a tunnel wall were to crack even slightly, the inward rush of water would have the power of a laser, cutting through everything in its path. Currents at this depth are not just slow flows. They are underwater rivers of immense power that can vibrate and snap massive steel cables like thin threads. Every piece of equipment must be redesigned from scratch to survive the dead zone, where the physics of the surface world no longer seem to apply. The sheer instability of the soil means that any heavy foundation would simply sink, disappearing into the bottomless mud of the rift within a few days. In this total darkness, traditional visual construction is impossible, requiring every action to be guided by precise acoustic sensors and advanced artificial intelligence systems. Thermal stress also plays a role, as freezing water temperatures clash with the heat generated by tectonic activity, causing materials to expand and contract dangerously. The risk of underwater landslides is constant, capable of burying miles of infrastructure under millions of tons of debris in a single catastrophic geological event. No conventional material can withstand these conditions for long. We had to look beyond the standard rules of engineering to find a viable solution. We cannot build on the seabed, nor can we dig under it. The answer had to be something entirely new, something that lived within the water. For decades, the brightest minds in structural physics wrestled with this paradox, searching for a way to bridge the gap without touching the treacherous floor. If we couldn't go down and we couldn't stay on top, we had to find the perfect middle ground where the ocean's power is most manageable. The breakthrough came when we decided to stop fighting the ocean's buoyancy and instead use it to our advantage in a way never seen before. Thousands of simulations were run to find the sweet spot in the water column, where the structure would be safe from both storms and pressure. This was the birth of the Submerged Floating Tunnel, or SFT, a revolutionary concept that would finally turn the dead zone into a passageway. This is SFT, the Submerged Floating Tunnel, a masterpiece of engineering that does not rest on the floor, but floats like a giant steel dragon. Inside these twin tubes, cars and high-speed trains will travel across the rift, protected by layers of advanced alloys and high-strength composite materials. The secret lies in the balance. The tunnel's natural buoyancy is carefully calibrated to push upward, while heavy ballast and anchors pull it back down. These massive tethering cables act like the strings of a guitar, keeping the tunnel perfectly stable against the constant push and pull of the currents. Located 30 meters below the surface, it is deep enough for even the largest ships to pass over, yet shallow enough to avoid the crushing pressure. Unlike a traditional bridge, the SFT doesn't care about the depth of the water. Its cost remains stable whether the ocean is 50 or 1,500 meters deep. Its hull is a sandwich of high-tech materials designed to be flexible yet indestructible, capable of absorbing shocks that would shatter a conventional tunnel. The cylindrical shape is perfectly aerodynamic, or rather, hydrodynamic, allowing the powerful deep-sea currents to flow around it with minimal resistance and zero vibration. Each segment is designed to be modular, locked together with precision-engineered joints that are both watertight and capable of pivoting during an earthquake. Advanced life support systems work constantly, maintaining air quality and temperature for thousands of travelers deep beneath the surface of the Great Rift. It is a silent, non-intrusive structure. While the world above rages with storms, life inside the SFT continues in a state of calm, high-tech serenity. Safety is the primary directive. Multiple redundant systems ensure that even in the most extreme scenarios, passengers have clear and immediate paths to safety. The SFT is more than just a road. It is a smart energy corridor carrying power and data between continents alongside the flow of people and goods. Thousands of sensors form a digital nervous system, allowing engineers on the shore to monitor every millimeter of the tunnel's health second by second. By moving the infrastructure underwater, we bypass the chaotic weather of the surface, ensuring that the link never has to close regardless of the storm. The mooring lines are made of advanced carbon fiber composites, stronger than steel but light enough to float, providing the ultimate stability in the abyss. Flexibility is its greatest strength. Instead of resisting the ocean's power with rigid force, the SFT moves with it, absorbing energy like a living organism. The land-based terminals are engineering marvels themselves, acting as the transition points between the solid rock of the continent and the liquid world. A dedicated team of experts monitors the SFT 24 hours a day, using AI to predict and prevent issues before they can ever occur. This is the pinnacle of modern physics, a structure that balances the weight of humanity's needs against the ancient, overwhelming power of the deep. The design is future-proof, allowing for the addition of more tubes or new technology as our transportation needs evolve over the next century. The road to realization was long and fraught with challenges, but the vision of a connected world provided the fuel for this incredible journey. It is a testament to what we can achieve when we stop seeing nature as an obstacle and start seeing it as a partner in engineering. Every single component, down to the smallest bolt, was reinvented for this mission, ensuring that no weak point would exist in this chain of steel. Now the blueprints are finished and the time for theory is over. It is time to begin the most difficult construction phase in history. The construction begins on land, in massive dry docks where each segment of the tunnel is cast as a single monolithic piece of steel and concrete. We use a secret alloy developed specifically for the Great Rift, designed to resist salt and pressure for over 200 years without maintenance. Robotic precision is key. Every layer of composite material must be perfectly applied to prevent any structural weaknesses under the intense pressure of the deep. Each of these segments is as tall as a 10-story building and weighs thousands of tons, thus making them some of the largest man-made objects ever moved. When the dry dock is flooded, these giants come to life, floating with just a few centimeters of clearance as they prepare for their journey to sea. A fleet of specialized tugboats carefully guides the segments out to the center of the rift, a delicate operation that requires perfect weather and timing. In the middle of the rift, the segments are handed over to massive crane ships, which will oversee the most dangerous part of the entire operation. The tolerance for error is less than 5 millimeters. At this scale, even a tiny mistake in positioning can lead to a catastrophic structural failure. Specialized ballast systems pump water into internal tanks, slowly sinking the giant tube, while underwater thrusters fight against the push of the powerful ocean currents. As it descends into the dead zone, the segment is guided by a swarm of remotely operated vehicles, or ROVs, acting as the engineer's eyes. These robots perform tasks that would be impossible for human divers, working in a world of high pressure and total darkness with perfect mechanical precision. The moment of connection is a high-stakes game of physics. Thousands of tons of steel must be aligned perfectly before the final seals can be engaged. A powerful vacuum system removes the water from the joint, allowing the atmospheric pressure to weld the two segments together with an unbreakable force. The first humans enter the new segment, walking through a space that just hours ago was filled with the crushing weight of the deep ocean. Deep below, specialized robotic drills are anchoring the mooring lines into the solid bedrock, creating the permanent foundation that will hold the SFT in place. The tension is carefully adjusted by AI-controlled winches, ensuring that the tunnel stays level even as the tides and currents shift around it. This process is repeated over and over, segment by segment, as the steel dragon grows longer, stretching further across the vastness of the Great Rift. Day and night, the work continues. There is no rest in the quest to conquer the abyss, as every hour brings us closer to the opposite shore. The conditions are brutal. Equipment breaks, currents shift, and the ocean fights back at every turn. But the human spirit refuses to be broken. Behind every machine is a person who has dedicated their life to this project, working in one of the most hostile environments on the entire planet. Science is our primary shield. Every rock, every current, and every pressure change is analyzed and accounted for by a global network of expert researchers. As the exterior is completed, the interior comes alive. Automated systems install miles of fiber optic cables, power lines, and the backbone of a new transportation era. The tunnel begins to breathe. The sound of life support systems fills the air, turning a cold steel pipe into a safe and habitable environment for travelers. From the surface, it looks like a city on the water, but the real magic is happening 30 meters below, where history is being written in steel. The final connection is made. The Great Rift has been crossed, and the dead zone has finally been tamed by the ingenuity and courage of man. But the ocean does not surrender easily. Deep beneath the rift, a magnitude 8.0 earthquake strikes, sending shock waves through the very foundations of the project. This is the ultimate test. The high-tension cables stretch like elastic bands, allowing the tunnel to sway safely instead of snapping under the sudden geological force. Inside, the advanced damping systems work in milliseconds, neutralizing the vibrations and keeping the interior environment stable and safe for the thousands of travelers inside. The SFT does not fight the Earth, it moves with it. This flexibility is the secret to its survival in one of the most seismically active zones. If a breach were to occur, the AI immediately isolates the affected section with massive blast doors, preventing a single leak from compromising the entire structure. Even a tsunami, which would destroy any bridge, passes harmlessly over the SFT. At 30 meters deep, the tunnel is beneath the reach of surface destruction. Accidents are inevitable. A rogue submarine collision tests the multi-layered composite hull, which is designed to crush and absorb impact like a car's bumper. The impact is absorbed. The outer sacrificial layer is damaged, but the primary pressure hull remains completely intact, protecting the lives of everyone inside the tunnel. Repair drones are always on standby. Within minutes, the damage is being repaired. And long before the salt water can even think about touching the steel core, the crisis is averted. The SFT has proven itself against the dead zone's most violent outbursts, standing tall against the absolute worst that nature can throw. Even in the face of danger, the tunnel remains a part of the ocean, a silent observer of the beauty and the power of the deep sea. Our testing was rigorous, pushing every material to its breaking point to ensure that no surprise from Poseidon could ever catch us completely off guard. The tunnel's thermal management system handles the extreme heat of the volcanic vents, maintaining a constant, comfortable climate for the passengers inside the Dragon. To the people inside, it's just another commute. They are blissfully unaware of the incredible engineering battle being fought just inches away through the hull. The system is alive, constantly adjusting itself like a master sailor, making thousands of micro-corrections every second to maintain its perfect, level position in water. The surface may be a war zone of wind and waves, but down here, in the heart of the SFT, the peace is never truly broken. It is more than a tunnel. It is a fortress of human will, built to stand the test of time and the fury of the ancient gods. We have faced the dead zone and won. The structure has survived its baptism by fire, or rather by water, and the future is now secure. The storm has passed, leaving behind a testament to human ingenuity that will stand as a beacon of progress for many generations to come. The day of inauguration has arrived. The first high-speed train enters the Great Rift SFT, marking the beginning of a new era of global connectivity. Traveling at 300 kilometers per hour, passengers can now cross the abyss in just 10 minutes, a journey that once took hours of dangerous sailing. One through the reinforced glass, a hidden world is revealed. For the first time, people can witness the majesty of the deep ocean without ever getting wet. The distance that once divided us has been conquered. Two worlds once separated by a vortex of death are now permanently and safely linked together. This project was never just about steel and concrete. It was about the indomitable human spirit and our refusal to accept the limits set by nature. Economic growth is exploding as goods and ideas flow freely between the continents, fueling a new age of prosperity that was once thought completely impossible. The SFT is a beacon of hope for future projects, proving that we can bridge any gap no matter how deep or how dangerous the environment. It stands as a legacy for our children, a reminder that with enough knowledge and courage, no abyss is too wide to be crossed by man. In the 904 seconds we have spent together is just a glimpse into a journey that took decades to complete and will last centuries. As we look toward the future, the lessons we learned here will lead us to build even greater marvels, perhaps even beyond the shores of our world. Thank you for joining us on this expedition into the heart of the abyss. The future is no longer a dream. The future has finally begun. The Great Rift is no longer a barrier, but a bridge, a journey into the once dead zone that has now become a path to the infinite.